We already know that maths is all around us, but can we apply it to our lives? Let's find out. Ebola, the Black Death, influenza. These are just a few of the diseases that have previously been halted. But who is to say that some deadly disease won't spark up again and wipe humanity off the face of the earth? Yes, we have better hygiene, immunizations, technology, and hazmat suits. But how long will it be before another disease breaks out? We have a growing population, and the next time something breaks out, chances are humans won't be able to keep up with it. Ebola was so close to infecting the whole world. It was just a streak of luck and hard work that kept it contained. But if our current methods aren't always successful, even at keeping a common flu at bay, what will happen when a deadly disease strikes? With maths, we will already be one step ahead. Mathematical models and equations can help us predict the spread of disease before it gets out of control. Mathematics is used to model epidemics. An individual will become infected with a disease if they are exposed to the disease. Patient 0, who is infected, may infect others depending on the contact between people in a group or population. The mathematics model assumes that people who become infected at a certain rate and infected people recover at a different rate, proportional to the number of people infected. This leads to a mathematical model that tracks the rate of infection and recovery of those individuals. These equations are solved together using the time series solution. It produces a graph which shows the rate that susceptibles and infectors increase and decrease over a determined amount of time. Here is a real-life example of a disease spreading approximated from the time series solution. In a class of 21, on day 1, there are 2 people infected with the common cold, as can be seen in red. On day 2, the disease has infected 6. Day 3, a further 8 are sick. Day 4, and all but 3 of the class are infected. And day 5, the whole class has fallen ill. Imagine the magnitude of the spread. If this model included a whole school, or even a city, take a deadly contagious disease, the whole world, and you've got a major epidemic on your hands. That is not the way the human race is going to diminish, because, as was just demonstrated, maths can be used to predict when and where a disease is going to spread, before it spreads. Action can be taken. Medical treatment and prevention measures can be concentrated to a certain time over a certain area, so humans have the upper hand on the disease, rather than chasing it like in the past. So, if you don't want the human race to end after going through a grueling uphill battle against an unbeatable disease, choose maths. It is the only way forward.